Here is Precalc. It's problem 8-46, and it says the graph of a transformation of y equals cosine x has the y-axis as a line of symmetry and 20, 50 as a point of symmetry. The line y equals 15 is tangent to the graph at many places. Write a possible equation for this graph. So there's a possible equation. We need to figure out why that makes sense, or that's even an equation that works. So let's just look at the information we have. It says the y-axis is a line of symmetry. So I know this is just the parent function right here. And in the parent function, the y-axis is a line of symmetry. So what that tells me is that if I want to draw it, it's not going to have a horizontal shift. So basically, it tells me that there's not going to be an H. Okay, and then there's a couple other things that I can figure out just by reading all this information. This is what was throwing me off. It says that 2050 is a point of symmetry. Well, a point of symmetry isn't what I thought it was. When I just read that right through, I thought, oh, it's going to be up here. It's a point on the line of symmetry. But that's not what this means. Point of symmetry doesn't mean it's a point on a line of symmetry. Point symmetry, I looked it up. You can look it up on the internet. I Googled it. Point symmetry is like this. That point is a point of symmetry for my letter S. And I can't remember the exact definition that they gave me, but it was something like the graph, all these points on this side of the graph are the same distance away from my point of symmetry as all these ones, but the direction is reversed. So there's a reversal of the direction when you have point symmetry or a point of symmetry. So in other words, like let's take the letters. They like to use letters of the alphabet. This right here is a point of symmetry for the letter Z. So to me, it feels like 180-degree rotational symmetry is what comes to mind when I think of that. But this is a geometry, kind of a geometry term that we're supposed to understand what that meant. And I was misunderstanding it, thinking it was a point that's on a line of symmetry, but that's not what it is. So that means that that point has to be one of these. You know what I mean? Because this would have point symmetry. See how it's like kind of S-shaped? So there was another piece of information. The line is y equals 15 is tangent to the graph. So when I saw that, I thought, oh, it must be running across the top and touching it over and over again. But it can't be on the top because I already tried that. Because 2050, it wouldn't be allowed to go high enough if that was just the maximum of the graph. So it's got to be going along the bottom of the graph, which is fine with me. So I know that there's this point of tangency, or what do they call it? The line y equals 15 is tangent to the graph at many places. So I know that's going to be like the bottom of the graph. So I'm going to just start trying to piece it together. So y-axis, here's the x-axis. Well, I'm going to draw in a graph with no numbers. I'll put numbers in later. So we don't really know how high it is yet, but we know it keeps touching the line y equals 15, so it goes something like that. We know that it has this symmetry right here, so if we can find where the top of it is, then we can get the midline to give us K, we can get the amplitude, we can eventually find the period. I think we're going to have to use this to get all the rest of the information. So we know there's a midline somewhere. I don't know what it is yet. And I know that I have point symmetry at 2050, which is going to have to be like one of these, like that one, that one, that one. So I'm going to put my 2050 right here. It's really the only place it can be. So that means that this is 50. And that means that this is 20. And then that kind of is going to help me unravel the whole rest of what's going on here. Now I know from 15 to 50, that's 35. And from 50, you know, if I go up by 35, I think that gives me 85. So that means my amplitude here is 35. We don't know what B is yet. Let's figure out B. Oh, we know what K is. It's 50. Let's put that in there before I forget. Okay, so we're just trying to find B. So we can find B. We know that if the graph starts here, then it's going to end here. We really want to know what that number is. I know that when I graph these kind of functions, I make these 5-point graphs, 1, 2, 3, 4, 5, and they always split my graph into 4 sections, like 1, 2, 3, 4. So like this is the halfway mark, that's the quarter mark, and that's the other quarter. It's not drawn to scale. But so this is actually 40. This one is 60. So this has got to be 80. Sorry that it's not drawn very beautifully, but just think about that. I think it makes sense. Okay, so this is the halfway, that's the quarter mark, that's the other quarter mark. Okay, so the period is 80. But we know that B isn't just the period. I can't just throw an 80 there. It's, I don't know if you remember this, but period equals 2 pi over B. Now I know what the period is now, finally. I got 80. 80 equals 2 pi over B, and then if I want to just cross multiply, I can figure out B. So there's B. So that I'm going to put that in for B times X. And then remember, I don't have a minus H. So it actually is, it does make sense. We got the same answer that they got. So that was a pretty involved problem. I think that one of the issues with the problem was if you didn't know what point of symmetry is, then that makes it a little difficult.